Thank you. Hey there, welcome. Hope you can all hear me. Good. Hey there, I'm Justin. I'm from a project called Smartmolen.com. This is a kind of community-driven IoT project, so I hope this talk is going to be a bit of fun, talking about the art of the possible, kind of what actually a small group of people can do in a small amount of time, and I think also a kind of really nice demonstrator that's publicly available online that you can all see, loads of data from sensors, loads of clever stuff, and quite fun to show people what's possible with the Things network. So, bit of context on who we are. I started this. I'm involved with a heritage windmill in the UK. It's actually recently been restored by a Dutch millwright. So yes, it's unusual actually to have a British person I know over here talking about windmills in the Netherlands. But here we are. This is December 20. The top of the windmill, the cap, was put back on. But the really cool thing about our windmills, which is a bit different from the ones in the Netherlands, is that they have this thing on the back called a fantail, and it turns itself around automatically to face the wind. So whichever direction the wind's blowing from, this thing on the back is turning it around to face into it. And it's really important that the wind is blowing onto the front of the mill rather than the back. So we get this scenario called tailwinding when it's blowing from the back, which is basically really bad. And let me show you why. So this is our problem statement in 15 seconds from Grietzil in Germany about 15 years ago. Wind blew from the back of the mill, cap smashed to the ground, 1.2 million euro repair project. We didn't want to be in that situation basically. So when we put our cap back on, there was a bit of a discussion, should we get a webcam? We'll know what it's doing, whether it's working or not. But I had a bit of background in medical technology and various other things, and I thought, well, no, we can do something better than that. We can work out which way it's turning and make sure it's facing the wind. So I had a bit of a challenge finding a suitable device, and ended up using electronics from the kind of folk who are available here to get a magnetometer, stick it in this kind of box, put it in the top of the windmill, and we get this constant feed of data from it. We tuck it away really discreetly in these heritage structures. We know exactly what it's doing, and then we get a nice little dashboard. This is an example of a shot. We now have this in a windmill in Bremen. You can see from this picture, at the time this screenshot was taken, the windmill is facing right to the southwest. The wind is blowing straight onto it. That's all great. We can do some nice little monitoring and analytics in the background to make sure it's facing the right way and it's not doing the wrong thing. So we started and we got to this stage about kind of 4 or 5 years ago. We just had our one windmill. We had this kind of very specific problem. We got out there, we did a bit of social media, said, look, hey, these windmills, we got all this stuff. And actually we got a lot of interest from other windmills in the Netherlands, in Germany and so forth. And people started saying, can we have more stuff? So for instance, a classic example, one thing everybody wanted to know, how fast are your sails turning? How many revolutions have we done this year? And actually with a very simple mechanism, again, we did a lot of trial and error, found the right devices. We're using a sensor from Arduino with a magnetic reed switch, simple mechanism to count, check the speed of the sails turning, and we can give people that data. For those of us who've got this fantail mechanism to know which way it's turning, we actually something a bit more complicated because this goes round both ways. It goes back and forth. But we thought, actually, we can do that. We can build a kind of bi-directional version of that and check which way it's turning. So not only do we know which way the whole cap is turning, but we know how's this wheel turning? Is that turning as we would expect it to with the way the whole thing is turning it round? And the project has sort of grown since there into a sort of electronic ecosystem of monitoring. So this is an example not that far from here, in a place called Rijn on Lech, just not far from Utrecht. De Hollandse Molen, who are the Dutch national charity for effectively windmill management, are doing a really important piece of research into something called the NB-IoT, which is all to do with the wind flow, the protection of the wind flow to windmills, basically. So in this case, we've installed a weather vane on the top and ultrasonic wind detection system, which combined with the data that comes from the windmill itself to tell us which way it's facing, is now, we're working with actually some folk at the University of Delft and so forth, but providing all that data to kind of understand the windmill environment and inform the next generation of research that's going on into that. So the project has sort of grown and grown. And LoRaWAN and the Things Network, I think for us, came along just at the right time, just after we started all this kind of stuff. This is an example, really remote setting. This is in Norfolk in the UK. I mean, windmills are perfectly set for the use of LoRaWAN because, we've got the sensors right at the top here in the cap of the windmill. The nearest gateway is actually 8.3 kilometers away. No problem at all with the signal. It gets picked up from miles around from those sensors. There's no power in this building. It's really remote, but the thing is constantly turning itself around. So we're monitoring it all the time. We know exactly what's going on. If, for instance, this whole gear system gets stuck, we can send someone straight out there to see what's happened and fix it before it gets into the state where it's got tailwinded. So we've got that fantastic monitoring on it from that distance. And we've ended up with this kind of this website we've put together. I sometimes describe it to people as a kind of Flight Radar 24 for windmills, basically. You can see all the windmills here that are feeding data into it. This was a screenshot from a few weeks ago. You can see which ones are turning. You can see which way they're facing. And we try and bring it to life and make sure that people can really understand what it's telling you by including some stuff like video as well, so everybody can make sense of it. So it's both kind of accessible as an education tool, and it's providing kind of important real-life data for managing all this stuff. When we're putting this together, we're kind of thinking through a bit of kind of how do we tell the story of all this stuff, and what do we think we've done that has made this work. So I've come up with 5 reasons why I think it's worked, I think it's worth sharing. I mean, we did the inevitable. Everyone will have done the trying a lot, failing fast. We went through many iterations of sensor, particularly to find the magnetometer. It was really tough to find a magnetometer that was reliable, worked well in the mill. For anyone, if there's anyone here from a sensor manufacturer, I'd love to talk to you about magnetometers and how we get reliable ones. We got a huge amount of data, but have spent a lot of time getting all those trade-offs right between the performance of the magnetometer, the timeliness of the data, the radio performance, the battery life, and we've kind of optimized the whole thing so we get the most real-time data possible, but we still get the battery life of a couple of years out of the. We ended up, we made good use of downlink commands and stuff, so we've learned how to tune the devices across the field to get those parameters right for our setting. We've got really great instrumentation and diagnostics, so everybody can see. We do a load of monitoring as we were tuning it on kind of how the magnetometer's working, how much LoRaWAN airtime the sensors are using and stuff. We make that available to our community. We've got a kind of we're building a kind of community. These people who are into windmills are getting quite into LoRaWAN, and they're all going, oh, we should change it to do this. And then we can see straight away, how the thing's working, how reliable it is. Spent a lot of time getting that right. We keep shipping out small. We get loads of people saying, "Oh, can it do this? Can it do this?" We're kind of on the full stack of it. We've got 4 or 5 people involved, from the kind of the sensors right through to the data at the back end for kind of what we're. And we're constantly kind of shipping out features. So, for instance, this one here, this is one that lots of our folk use a lot. It's a little graph that shows you the dots of the wind direction, the wind speeds. This is kind of north to north again, and the black line is how the top of the windmill has turned round, and you can see, these are 2 completely independent measurements, but they've tracked each other so well over that period of time. So we do lots of good stuff on the data visualization. Our tech stack, it's LoRaWAN and the Things Network at the front end. We use Azure functions and React.js at the front end, so it's really cheap and easy to run, scales really elastically as the demand grows. And as I've alluded to earlier, we do this stuff about kind of really trying to bring the data to life. So in a couple of cases, we've got the mills complemented with the cameras and so forth, so that when people are looking at it, although we're really ultimately interested in the sensor data, we let people see kind of real time what's going on. So a few more little stories to tell you about where we've got with it. I like to think we're starting the process of doing what we call smart mill writing. So, we're starting to think, well, actually, should we, things like because we're monitoring sail revolutions, every 6,000 revs, people are starting to go, well, actually I found, yeah, actually every 6,000 revs is the time to check this or replace this. That kind of, we're kind of making that more scientific and modern in its approach. Lots of people who are using the sensors are kind of telling me those stories about how they've found that useful, and they're also sharing them within their own windmill community, which is quite cool. So they're all chatting to each other in a WhatsApp community we've got going. Oh, I've started finding that yeah, I should do this every 10,000 revs or whatever. We're doing some stuff on STEM education. I didn't have a direct picture of them using the website, but we've got some schools using it for science, geography, engineering type things. We've got some question sheets they can take home and look at the wind at different windmills, all that kind of stuff. And we do some kind of fun stuff. So we've built this little league table of windmills and how much they turn every year. We call it the windmill whirl-off. So we're doing all sorts of different things on engaging, and people are actually getting quite competitive. My windmills turned this much relative to yours this year. So we're both trying to make it useful and fun at the same time. In terms of things we're doing next, we don't know exactly. We just keep talking to more and more people with windmills across Europe. We've got lots of interest further from the Netherlands, Germany, etc. In terms of why I'm here, very happy to chat to other people about kind of all sorts of topics, including sensor design, gateway coverage, which is obviously a thing we're interested for with these kind of environments, dashboarding, user interface design, the kind of big data at low cost, and the kind of community engagement piece, getting people out there to know more about LoRaWAN, what it can do and so forth. But yes, in short, that's me. We're doing this to keep windmills turning. Hope you found that to some extent interesting and fun. A minute or two if anyone's got any questions. Okay. Great. Oh, sorry, yes, just.
So I have a question about data. How much data per windmill do the sensors produce?
Oh, so a good point. We've now got about 7 million records in our database, and I think per windmill it's like 100, 200,000 data points per year, depending precisely how many sensors they've got. So yeah, no, that's, so quite significant-ish, not huge, but exactly, yeah. So yeah, so it seems like that.
So do the sensors send the data like online? So every time they take a measurement, they will send the data, or do they make batches and then send the data in batches?
So as is traditional for a lot of LoRaWAN sensors, it's just a reading of the data as it stands every 20 minutes or so. We do some clever stuff to try and optimize it on the time of day and the likelihood it's likely to be turning and so forth. But basically, it's the data comes off the sensor straight away and straight up to the cloud via the Things network. So yeah, cool, brilliant, good.
I'm sorry,
that's good.
Answer for the questions outside.
Great, that's great. Yes, happy. That's great. Oh, cheers. Thank you very much. Thank you.